Hello and welcome, dear students. So, we welcome you all in this first unit and first class of pre-stress concrete. And today we are going to understand what is pre-stress concrete, when it is used, what are the types of pre-stress concrete, and what is the advantage of pre-stress concrete, and what are the disadvantage of pre-stress concrete over traditional reinforced concrete. So let us begin, as we have studied that concrete is very strong, very robust to resist compressive forces. All right. But when it comes to the tensile forces, their strength is really less. Okay. So that we have checked in the labs also. And concrete feels like a brittle material. So when we check under the laboratory, the cracks starts developing, propagating like this, as shown in the diagram. So when we go for the design of the structure, we design the structure as per limit state using two conditions. One is the limit state of strength, and under that limit state of collapse, and in that structure should not collapse and it should be well within the ultimate strength only. Second is the limit state of deflection, and in that we satisfy the deflection upon a span length up to a ratio. Okay. And when the structure starts collapsing, then the cracks start propagating in this structure, and due to these cracks the water can penetrate inside the structure easily, very easily, and due to penetration of water, the steel reinforcement that we have provided in reinforced concrete will be corroded, and when they will corrode, the entire strength will be decreased very drastically. So to avoid cracks propagations and to increase the strength of the element and to reduce the deflection, we are going here for pre-stressed concrete. Okay. So pre-stressed concrete figure here is shown, and you are seeing some steel reinforcement coming out here, and these steel reinforcement are called as tendons in the language of pre-stressed concrete. And these tendons or steel reinforcement are anchored here with certain mechanism as shown here, and they are jacked here in the anchorages, and there they are applied with certain stresses. So here we do the pre-stressing, as the name suggests that we are already tensioning the reinforcement beforehand only. Okay. So when we go for the tensioning of reinforcement, such a concrete will be called as pre-stressed concrete. Now, why the need of pre-stressing came into existence? Let us try to understand. If we have to go for the design of a mega structure like a bridge with a long span without any intermediate supports, so in that case, if we use traditional reinforced concrete, then what will happen? Because traditional reinforced concrete have got very less strength. And if we have to design a large span length beam here, and those beams are called girders in bridges. So girders will be having a very deeper depth here. Okay. And what will happen, the depth of these girder beams will be very high. Okay. And in that case, if there is a ship which has to pass through these bridges, then it will be an obstruction in that case. So we want lower depth, we want longer span, and we also want more strength here. So achieving all these three characteristics is possible when we shift to the use of pre-stressed concrete in the place of traditional reinforced concrete. So these are the special benefits that pre-stressed concrete gives us in comparison with traditional reinforced concrete. Now, how these special qualities come into pre-stressed concrete, that also we will understand very soon. So you can see these are the actual figures of pre-stressed concrete girders. So in that we try to understand first of all that some transverse loading is coming onto the beam, and beam is deflected like this, and on the top region of concrete compressive forces develops, and at the bottom regions tensile forces will be developing, and due to which cracks will propagate from the bottom. Now here we have used only traditional reinforced concrete. But now we are going to make this same element a pre-stressed concrete. So here what we have done, we have uh, applied a tension forces through a tendon, through a steel reinforcement here. Okay, and we have applied tensile forces at the bottom of the beam through these tendons. So what happens, tendons have got tensile forces. So these tendons will resist these tensile forces by the bond action with the concrete in the bottom. So concrete in the bottom zone will develop compressive force to resist this tensile force in the tendon. So here this steel bar, which is pre-stressed, is going to save the concrete from cracking, because concrete in the bottom zone is in the compressive now. Okay, why this compressive force is generated? Because we have applied a tensile force in the tendon, and to resist that, by the bond action with the concrete has to be under compression, and due to that the curvature will look like this. And here we can resist higher magnitude of load in comparison with the traditional reinforced concrete. So this is the basic understanding of pre-stressed concrete, and with the help of pre-stressed concrete we can design different elements like slabs, girders, longer span bridges, and these all can be longer unsupported spans. See, we are going for longer spans, and that too unsupported, without any support in between. And we also design school auditoriums, shopping centers, malls, gymnasium, parking garages, and cafeterias with the help of the PSC. So PSC is the acronym of for pre-stressed concrete, and these are the pictures of sleepers and different pre-stress concrete where it is used, like water retaining tanks or runways or poles, or for making of roads. Okay, so this is where we use pre-stressed concrete most frequently. Now how this pre-stressing is done? It is done with the help of basically two methods. One is the pre-tensioning, other is the post-tensioning. Okay, now how we do pre-tensioning? Let us try to understand it. As the name suggests, we are tensioning the steel reinforcement before concreting. So such a pre-stressed concrete will be called as pre-tensioning pre-stressed concrete. So here we first of all make a precasting bed, and on that we arrange the anchorages, and with the help of those anchorages and jacks we attach the tendons. Okay, and these tendons are stretched against the end abutments. So here you can see in the diagram the tendon is shown and it is stretched from left side. Okay, and on this precasting bed we stretch to up to 70 to 80% of the ultimate strength of tendon, and then we power concrete on it. Okay, and till that we cast the beam concrete, and we allow it to cure it for 28 days. After curing is done and concrete is set, now we cut the indent coraces, and the beam is set to be pre-stressed concrete. Okay, now here tendon bars is stretched with certain tensile forces. Okay, and when the concrete bars set, when concrete bars completely cured, now this tensile force in the tendon is resisted by the concrete by development of compressive forces even at the bottom. Why this compressive forces developed? Because of bond action, and due to the bond action from Newton's third law, we can say that for resisting equal amount of force, we have to apply an equal amount of force in opposite direction. Okay, so compressive forces of equal magnitude develop at the bottom, and that beam will be said to be pre-tensioned. Pre-tensioned, that means concreting, before concreting we have pre-tensioned the steel reinforcements. Okay, here we are showing you only those pictures which are already precasted in the industries, and they are transported to the site and they can be used. So generally Pretensioning is done in the industries or in the shops, and there pretensioning is done, and it is allowed to cure for 28 days, and after the curing is done and concrete is set, then we can transfer those elements to the site where it has to be used. Okay, and there are different places where we use this pretensioning, and for pretensioning we use different tendons like a steel reinforcement, or even we can use cable wires also, and these cable wires are made of steel. All right, so this is how we do the pretensioning. Okay, and we use pretensioning pre-stressed concrete in foundation pile, railway sleepers. You have seen the electrical or lighting poles in case of floor slabs or certain beams, pipes, or partition walls. So all these elements are casted in the shop or the industries or at certain places, and then they are allowed to cure and set, and then they are transported to the site where they have to be installed. Next is the post tensioning. As the name suggests, we tension the tendons after concreting is done. Okay, so here steel reinforcement is stretched after concrete hardens completely. Okay, it is usually carried out at project site. Okay, as the pre-tensioning was done usually on the shop or industries. Here, first of all, we cast the concrete. Okay, and in that concrete we allow a duct to pass through, and that duct is also said to be in another word as sheath. So through these ducts we pass through the tendons, and after concrete was set, and through these ducts we pass through the tendons, and we apply a jack at the ends, and then we screw it so that the tendon is stretched. Okay. So this is how post tensioning is done. First concreting is done, and then after concrete was set, then we put the tendon in the duct, and then we apply the jack, and then we apply the pre-stressing forces there, and the excess ends of tendon can be cut away anytime. So you can see in this figure what is a steel duct. Steel duct is basically a hole passing through the entire concrete from one end to other end. And here you can also see tendons very clearly. Tendons can be one cable or it can be a combination of cable. Now what is cable? Cable is a group of steel wires, and they are arranged in sometimes in a group of 6 or sometimes in a group of 8 or 12 like this. And we can take a group of cables also, different numbers of cable like 12 cables, 15, 20 cables, like that as per the need. And maybe sometimes duct may have to be filled with grout. Okay, so either we can fill the duct with the grout and then cut the jack, remove the jacks, or if we are not going to fill the duct, then we have to keep the jack installed there only. So now onwards, if you go below any bridges or any flyovers, try to look from the beneath also and see at the ends of the girders. You will surely see the jacks and tendons coming out. Okay, so this is entirely shown in this picture, and you can see how post-tensioned pre-stressed concrete is used in roads, bridges, railways, tunnels, dams, containment tanks, reservoirs, underground constructions, foundations, buildings, industrial facilities, and air and seaports, and all these structures are special structures. So post-tensioning is done in all these cases. Okay, and post-tensioning, remember, it is always done at the site itself. So there are a lot of advantages of pre-stressed concrete. One is that the design is very sleek and slender because the strength is very high. Okay, and due to this, the dead load of the structure itself reduces, and hence we can say there is less consumption of the material. Okay, and it reduces the cost also subsequently. And this is another picture of a pre-stressed concrete. And due to less depth of the beams here, there is untroubled floor space and parking facilities, or we can allow the larger ships to pass through the bridges. And there is also long-term durability also for the pre-stressed concrete, and there are no easy way of for development of cracks there. So if the cracks will not develop, the reinforcement will not corrode. Okay, and in our city also there are flyovers which have used this concept of post-tensioning pre-stressed concrete. Okay, they are also having very excellent fire resistance and low maintenance cost. Oh, now what is the maintenance in pre-stressed concrete? Yeah, one maintenance is very important. Maybe after certain interval of time, the stress that we have imparted in the tendons may reduce with time because of loading, certain repeated loading. So we may have to tight the tendons again at the jacks. Okay, so that the tendons restores its initial force conditions. Okay, so that maintenance is very important, and that is usually done in all those bridges at a certain interval of time. They are also having greater load resistance as well as shock resistance. But there are few disadvantages of pre-stressed concrete. What can be the most common disadvantage here? Here we require very high quality dense concrete, and that too of very high strength. Now concrete also has to have very high quality, and it should be dense, and it should have very high strength, because these concrete will be also subjected under huge compression. Usually in simple traditional reinforced concrete, the concrete can be M20, M30, M40. It is sufficient. But if we are going for pre-stressed concrete, we must have to go at least M50 or M60, nothing less than that. And the normal steel bars that is used in pre-stressed concrete, that is also 2.5 to 3.5 times costlier than the milder steel which is usually used in the reinforced concrete. So these steel bars are also having very high strength, so they will be costly. Okay, so ultimately the cost of pre-stressed concrete is very higher, and they have to be produced by maintaining a good quality control under supervision, and they required a skilled laborers also. Okay, so if you see, for shorter spans and lighter loads, these pre-stressed concrete becomes uneconomical. So if the question comes that why we are going for high strength concrete, yeah, one thing is very genuine, that we have to go for high strength steel bars for providing as a tendon in pre-stressed concrete, because these tendons are stretched with a huge amount of stress at the bottom. But the concrete surrounding the tendon also have to have a huge strength, because ultimately that tensile force that is applied on the tendon is registered by whom? By the concrete only. Concrete develops compressive forces at the bottom by the bond action, and that huge amount of compressive forces can be beared only when the concrete is having very high strength. So that's why we provide very high strength concrete for pre-stressing. And you can see in this diagram that when we have provided a concrete of lesser strength, and when we have pre-stressed the beam tendons here, then immediately after pre-stressing the crack have developed. There are horizontal crack, there are Y crack or the vertical crack, and there are inclined cracks. So all these cracks develop because we have used concrete of lesser strength, or there must be not proper compaction of concrete there, or there may not be proper production of concrete at the site. Okay, maybe the quality control would be lesser, or it must not be done under proper supervision, or the labor may not be the skilled. Okay, so higher strength concrete have also some more beneficial features. Okay, because they are lesser subjected to shrinkage cracks also, And these high strength concretes also have higher modulus of elasticity and a smaller creep strain. So all these properties of high strength concrete makes it a perfect material for use in pre-stressed concrete production. So with this, we would like to end our class here, and we will be discussing more in detail and venture through this topic in the next video also. So till that, stay tuned and stay safe. Thank you.